Thank you very much again for the introduction, Jonathan. We're really pleased to see the level of interest for this webinar today. It's Graham and myself here. Graham, do you want to say hello as well?
Sorry. Hi, good morning, afternoon, wherever you are.
That's right. And along with us, we also have several colleagues joining us in this webinar, also ready to answer questions in the chat if you have. So feel free to ask there. And this is not the first time we've done this webinar. We are here for a number of times already and really enjoy the dialogues, both during and also after the session. So that's something that we really much welcome. We're all here because we are stakeholders in the energy industry. Either you're project developers, you may be a supplier, or you may be a customer or an investor in this industry. So during the most recent webinar in September that I held together with Audrey Goulouven-Priori, we did introduce virtual twins to be the proposed backbone of an industrial approach for offshore wind. We also there introduced Dassault Systèmes briefly. So we're going to skip that this time, but basically go to the topic of describing Dassault as a solutions provider for generative virtual twin universes, where we use modeling and simulation to imagineer the future energy assets, and also generative AI on real-world evidence to learn from previous projects so that we can excel and drive quicker time to energy. So what we're doing as Dassault Systèmes is to help the energy industry to mature the adoption of virtual twin technology. So why is this important? Independent organizations, plus also ourselves, believe, based on cases, client cases, that we have reasons to believe that virtual twin technology and the solutions can really help the industry with the major challenges of complexity and handle risk. So let's get into it. And let us now imagine that we are in the shoes of an energy project developer. And we'll imagine the virtual twin journey for such an energy project developer. So if you follow the green arrow at the top, the energy infrastructure project lifecycle, we are looking at a long, lengthy, many years process. And as an energy project developer, we also have a portfolio of several projects running at the same time. And we are collecting immense amount of knowledge that we would like to reuse to avoid cost or delays that we've had from previous projects. There are several stages here, but what we're going to do in the webinar today is to focus on the very early phase. The early phase where we start a new project and we go through to concept design and before we entered all the detailed design. This is also following the arrow at the bottom where you initiate a new energy project until you come out at the end with a winning bid. What we're going to see is also that it is that during this phase, when your activities, there are things you can do to decrease the risk, but also increases your chances of winning the bid at the end. So what are the topics we're already doing? So as an energy project developer, you will already be working on your business case and initiating the traceability of all of your decisions. You will be working together with stakeholders to get buy-in and to follow requirements. You will also work and collaborate with your supply chain to ensure the readiness and efficiency once your project is up. This is also the time when you're estimating the technical solutions, the cost, the clients, the infrastructure, and all the other aspects that you need to do in order to have a viable project. What we're going to do during the webinar today is to take a look at how we, during these steps 1, 2, and 3, how we can advance the way we perform these activities. What is it that we can do with virtual twin technology during those steps? Virtual twin universes in order to excel and do them better to increase the chances of producing the winning bid and also reducing the time to energy. So let's start with the first one. In step one, securing the business case and initiating the digital continuity and end-to-end traceability. Here we want to manage the complexity and reduce the risk for us as a project developer. Okay, it's time for imagination. Let's imagine we are company leaders in a renewable energy enterprise called WaterBreeze Ltd. We are looking at an offshore wind site and we are looking at the tender requirements. So what we're suggesting here is to start by describing our entire enterprise with a model-based system engineering approach so that we can connect them to the requirements management. This sounds like a simple step. There's quite a few steps towards it, and I'm now going to flip through the main schematics of how we get there. The icons are quite small, so I don't want you to pay attention to the detailed text, but rather the flow. So the first thing the WaterBreeze company would do is to describe the enterprise model in a systems model. The next would be to also model the stakeholder needs in the same systems engineering approach and describe the concept model of the business case in a systems model. And then being able to run financial viability simulations. So the new situation when the tender comes in would be to take the document-based tender requirement, the bottom left, produce the model-based requirements, and then connect it to the enterprise model. That was a quick round tour. Graham is now going to take you through a demo to show more of the details.
So yeah, as Annette mentioned about the enterprise modeling, we've modeled the enterprise. We're responding to that model now, the drivers, the challenges, the business, the goals of the organization, and really modeling at a system level, a system being an independent system in its own right, but connecting multiple systems in a network of system models. The video seems to have paused.
You're right. Let's see, why is it paused? Let's continue there.
Yeah, so using our Katia Magic solution, we're taking a model-based approach to investigate and explore the different opportunities that might address our business goals. So we've got modeling, modeling the different solutions that we have, the different options, having parametric models that describe the different technologies, the different assets that might be part of our solution, our energy solution. Being quite agnostic at this stage, exploring all the different opportunities, exploring new technologies and seeing what they can do within our need, and then modeling trade studies, utilizing the different parametrics that we can attach to these models, taking what is a very complex system of systems down to very simple block diagrams described by parameters and attributes and how the relationships between those. And once we've got that model in place, we can start to simulate, here obviously rapidly accelerated, but simulate with different variability the different outputs, the expected outputs, maybe financial viability of our systems. As we run through those trade studies, we can obviously take a specific trade study, focus on it, and run futuristic assessments. So looking 10 years in advance, changing the variability automatically and coming up with the results. Here we see a bit more focus on the system level, but it's really the principles of the system traceability that we have. So we've started off in a model-based approach. We're developing and understanding our requirements in a much more robust manner. Because we're using models, we can do a lot more. And now we're connecting those requirements through, in this case, to our functional architectures, our logical architectures, and through to our CAD results, as you'll see in a second. Functional architectures are describing the functions that are needed to address the requirements. And as you can see here, we've got the traceability through this what we call system traceability widget. And you can see the relationships of how we're addressing the requirements on the left with the functional architecture on the right. It could be the logical architecture, which is a plant breakdown structure. With all the time getting access to the detailed requirements, as you can see on the right-hand side, as we select through those models and those artifacts. We can show an impact mode. So this is giving us a full end-to-end traceability through our models. So here we've got that logical breakdown structure, your plant breakdown structure, or your product breakdown structure, however you want to describe that. That is giving us the equipment that we've identified that is addressing the functions and the requirements, down to, on the right-hand side of that picture there, you'll see in a second the CAD data, if that's what we want to bring in to our scope, that addresses the equipment. So because we're working in a digital manner, we can simply drag and drop to have access to, in this case, the CAD structure. Could easily be space allocation models in this early conceptual phase, or if you're reusing assets, it's the detail widget. Just popped on my screen. Sorry. And we can go as far as we can with that detailed traceability, utilizing different models. Back to you, Annette.
Thank you, Graham. What I think is very interesting with the topic number 1 that you described is that this can be applied on the technical level on the requirements, but you could equally well put that to legal or permit requirements, so security requirements, and any other business agreements that you may have. So I think it's really very multifaceted. Fine. But anyway, so topic number 1, manage the complexity and reduce the risk by describing your business case in a system of system models, and also connecting that all the way through to requirements. So let's take a look at topic number 2. So you are already, as an energy project developer, interacting with a lot of stakeholders. The ecosystem is great. You got your investors, the ones that believe in the project. You got the technology providers. You got all the legal and permit topics you need to adhere to, and all other kinds of navigations to take care of, plus grid connections and so on. So stakeholder engagement is something that we see that a lot of time is spent on, and there's also a lot of really nice outcomes that come from the stakeholder engagement that can enrich the requirements and enrich the end business case. So what we're going to look at now is how you can use the stakeholder engagement and up the game there and increase the level of alignment to reduce the time to decision. And as we all know, if we can reduce the time in this early planning phase, the quicker we can get to energy. So what a lot of renewable energy companies are already doing is to work with all kinds of geological data. This is what we see in the middle here. This is fairly easy to overlay and get all the kind of different maps and GIS data integrated. What we hear from the industry is that as soon as you want to start integrating subsurface data or kinds of ecological data or other types of sample data that you have from several different consultancy companies, you immediately have to step out of your environment where you are. So the red plus symbolizes a data silo, a data bridge that is not real-time updated. Similarly, as soon as you want to include your asset CAD data, any kind of 3D models, or start doing some layout optioneering, this is also done in a different silo. So that also poses a risk because there are version controls, and throughout your stakeholder dialogues, you're capturing feedback and information and wish or hesitations that would really need to be captured. What we're now proposing is that by upping the game, and this is where the Dassault solution 3D Experience platform can make sure that you don't have red pluses, but actually fully integrated data is where you bring it all together. So connecting a multi-layered site-relevant data and the CAD models of technical assets in context for the entire capital project. So this is a real advanced way of working that can benefit and really ensure that you have those valuable stakeholder dialogues, which can both be very valuable for investors to see, the society, and all kinds of technical aspects when you would like to discuss with your supply chain. So what does this look like in a demo?
Yeah, so what you're going to see is one of our apps from our Geovia brand, which is a brand that's involved with mining, so subsurface technology, but also presenting all of that data, the GIS views, the map views, addressing the different stakeholders that Annette referred to. So we've got we can show shipping lanes, we can show protected environmental spaces. Here we're optioneering, so taking that system and trade study approach earlier, we're starting to present the different options that we've got within this sort of interactive background, interactive viewpoints of our systems. So you're taking a city view that maybe addresses the public's perception of what could happen. Here we've got visual representations of the different options. It could be offshore wind, it could be, in this case, maybe a hydrogen plant, the different locations that we're sourcing, all geolocated. So these are actual geolocated models. And as previously, we can connect to the actual development models, in this case, that we can then open and explore to understand more. So here we've taken that, the 3D, again, that CAD data of a representation of a hydrogen facility. We can see the engineering item structure on the left-hand side. So we've gone from a very, very high level visualization of GIS data into this deep understanding of the technology that we're going to implement, utilizing the relationships that we've got held within the database. Again, back to that system traceability aspect. We can take, in this case, the product structure and review the relationship that it has. Maybe any related documents that we can open directly into a viewer, or the connected systems. So we've got logical systems, we've also got its requirements. So we're really understanding and bringing together all of those stakeholders to, as Annette mentioned, enrich the requirements because of a greater understanding of the options that are being delivered that fulfill the requirements that have been set. We're going to enrich those requirements because of that greater understanding. And it's, as I mentioned before, taking that system thinking approach and all those trade studies that we've assessed early on and presenting those over that 3D world.
Thank you, Graham. So we've reached the third topic where we see that there's slightly different transformative ways of working. And now we're going to take a look at the activity of collaborating efficiently with the supply chain. So we all know, as an energy project developer, we are not delivering any project without a reliable supply chain on time with the support when we need it. So let's take a look at this. If we are the project developer, we have the full overview or want to have the full overview and risk in order to control the end quality, the business processes, to make sure that we track cost and time and stay on schedule as promised. And this is all part of the very early phase as well, because as we're there to estimate a bid, we need to be fairly sure that what we're saying we can do, we can also do. So in this phase, improving supply chain collaboration efficiency, we are proposing to go from a document-based work package way of working and normal exchange to a continuous digital collaborative community and continuity. So as an energy project developer, we want to instill that digital continuity to minimize the risks, so avoid silos and make sure that we have access to real-time data all the time. We also want to provide our entire supply chain with a secure collaboration space. So avoid all kinds of exchange in documents, emails, and all kinds of shared spaces where versions and updates easily get lost. And we want to keep a very tight control of business processes to ensure the quality. And one example here is interop. The supplier or OEM still has the freedom to choose the best-in-class design and planning tools that they choose to do. But in the interface, when interacting with us as an energy project developer, we really want to make sure that it can all be ingested in the correct way, ingested and federated. So what we're suggesting here is that the Watt Breeze Ltd are able to keep control of quality, process, cost, and time by integrating everything into the 3D Experience platform, but still allowing the OEMs to use the best in-class tools of their preferred choice. So what does that look like? Let's take a look at the wind park, the component supplier of the turbines, the foundations, and the blades, the entire set out sea. You also got the e-fuel production site on land, that it comes on time, is installed and up and running on the right time. And then, of course, all the supporting civils works, which is typically not so much components, but more perhaps a program schedule and the project management time schedule. Of course, all the other aspects, the cables, substations, the supporting roads, the port, potential expansion of that, and all grid connections, and also fuel storage and any other aspects. And here we haven't even begun to mention the human resources that are needed. So planning that we have the right skills at the right time, and also making sure that we really avoid that. So it's all about the scheduling, but keeping also very tight control of that. So in order to improve the supply chain collaboration efficiency, Graham is now going to take you through a few snapshots of a demo to explain it further.
Yeah, thanks, Annette. So in this first example, I think we've got a manual approach. We're demonstrating a part of a process. We're not going to take the first part of this process, but it's a collaborative process between an energy project developer, and an OEM. And we're going to take a bunch of requirements. I've got a feeling the video stopped. There we go. A bunch of requirements and show how those can be released within the database and shared to the OEM, who is then going to respond to those same requirements. So here we're taking increasing the promoting the lifecycle state to a release state of these individual requirements that could have been brought in from many different sources. We have connectors to 80 plus requirements management tools and model-based tools that allows us to ingest and federate data into the database, into the platform. So here we've taken that data, we've frozen it, we've moved it and shared it into a specific collaborative space that the supplier can get access to. And what we're doing here is providing a dashboard that the provider, the OEM, is going to have access to, and we're providing a set of requirements, in this case, the system requirements. And we want the OEM to respond with his subsystem requirements to this set here. So what we've done is shared the dashboard and the requirements with the specific OEM, which then receives that sharing through, in this case, email notification. We could have other notifications are available. But so we're really collaborating, staying within the platform. That this is the OEM's view. Is marking his task as in work. So the developer immediately sees that this is being worked on. He's got access to those requirements, but he's chosen to take a different view on requirements and author in the tool that he has typically deployed in his business, in this case, IBM Doors. So in modeling the response to those requirements, is that those subsystem requirements are then available. And we've got connectors that allow us to, in this case, drill into the Doors database and connect specifically to a space within the Doors database and access the model directly. And here what we're doing is building that relationship. We're saying our subsystem concept design requirements are meeting the higher level requirements. And we can connect those individual artifacts up. The red box there indicates actually there's a bit of a problem in our the OEM has got a requirement that there's no home for it to go to. In that case, the developer hasn't provided a requirement for power in this particular case. And then, so quite simply, though, we're utilizing that task and that collaboration to, in this case, create a review object around our model on our dashboard. A review object is very similar to a comment in a Word document, but in this case, it's a digital object in its own right that can be shared. So we can take that review object and attach it directly to the task. So we're not leaving the platform. We haven't got stray emails. We're not creating documents that describe the situation, and we're not adding other document-based requirements that break digital continuity. Here we're staying in that platform, and the result of that is the developer has provided that additional requirement on the left. The OEM can attach his requirements, and now we've got fully covered requirements. And finally, we can sign off that development and move the task to complete. Okay, that was a manual approach. We have an automated approach to the whole business process. And Annette mentioned in the previous slides, Interop. So Interop is a tool that we have within the platform that allows us to automate quite complex business processes, whilst at the same time providing a simple, easy to use interface. So here what you see rather quickly is quite a large process for model-based surveillance of our system that allows us to select the criteria of what we want to monitor and attach and involve all different actors into this process. Here we've got the set of requirements that we can review. So we've got the review abilities, and by setting the criteria up front for the different disciplines that are involved, in this case piping, tubing, we've got a set of deliverables that are available. So we've set a process that is now allowing us to define the deliverables that need to be addressed within this stage of the program and for this particular discipline. And you saw there the receiver of the task uploading the documents, and that process follows all the way through. I've cut the video short, but yeah, that process follows all the way through until completion, but is fully automated and fully managed. Annette.
Thank you. So that was topic number 3, how to improve supply chain collaboration efficiency, really to bridge those digital gaps or areas where there can be risk for data loss or inconsistencies, which allows you as an energy project developer to keep control of the quality, the process, the cost, and of course also in the end time. So we've come to the end of the webinar here. I'm just going to spend one slide on summary now, looking at what we're hoping that you've received with you now is to a way to gauge, is there something that you could start doing differently for either point 1, 2, or 3? Is there a way you could integrate model-based systems engineering into your business case? Could you do your requirements management more digitally to ensure traceability all the way through from enterprise to project and down to component level? And that would allow you then to really reduce the early risk that you may be inserting at the early stage. The way you interact with stakeholders, was there anything in there today that you're not doing that you would like to start doing? This is exactly what we're helping energy providers out there today to do. So to connect those and bridge the silos to make sure that you don't need to flip between systems to look at CAD data and all types of other geolocated data, but really have it all in one. So data federation is a challenge out there today. So if you're seeing something that you could improve there, let us know. We believe that stakeholder buy-in and the times and the dialogue there really can increase the level of alignment and reduce the time to decision. And the third point then, the supply chain collaboration efficiency, really getting to that. Let's use an owner-operator to take control of the quality, the total cost of ownership from a very early beginning. So we've looked at only the little top left quadrant of this entire energy infrastructure project lifecycle. But if you recall, at Dassault, we're supporting energy industry with Imagineering, using modeling and simulation on very complex virtual worlds to learn and excel the information we can have from the real world projects, and also AI and other solutions to ensure that we can learn from previous projects in our portfolio to avoid mistakes that we've been doing before as we collect more and more information. What we would like to ensure that we are helping the energy industry with is to speed up the process for positive tender processes with the winning bids at the end, where you also, when you win the tender, you feel secure in that you've actually looked and turned and flipped all the types of risks that you can see, and that your supply chain is ready to go. Thank you very much for your participation.